You are seeing there are two figures given in the screen. What type of compound these are, what they are showing, which type of isomerism they are showing in this figure, and what will be the other type of questions in this type of compound. So my dear students, now we are going to explain the what type of isomerism these compounds are showing. These are the geometrical isomerism. In this GOC lecture number 12, we are going to study about the geometrical isomerism and their related to question. You are watching this video on the Chemistry Career channel, and I request you to subscribe and on the bell icon so you can receive the new videos immediately. Without wasting the time, we are going to explain what is the geometrical isomerism and this question, what is the geometrical isomers of these compound and what will be the names of this compound, and this compound we will explain in this video. So let us start from the starting of the geometrical isomerism. Students, if the compounds containing double bond between the carbon, they can show geometrical isomerism. That means it should be C double bond C. There will be 4 bonds in carbon and 2 bonds between the carbons and carbons. So there will be 2 more single bonds in every carbon. It will be 2 more single bonds. In these 2 bonds, if different groups are attached, suppose here is X group and here Y group is attached. Similarly, here X group and Y group are attached. So these type of compound can show geometrical isomerism, and they can be explained by drawing the structure in different parts. There will be 2 types of the geometrical isomers existing when the carbon double bond carbon present in any case. So compound may be XYC double bond C XY. This type of compound may show geometrical isomerism. One example I am going to you. Suppose ClHC double bond CHCl. This is a compound which can show geometrical isomerism. Or you can say CHCl double bond CHCl. This compound can show geometrical isomerism. So there are 2 types of geometrical isomers. That is, one will be the cis form, and another will be the trans form. Cis form and trans form. What is the difference between the cis form and trans form? So we are going to explain how we can draw the cis form or trans form. So if you are having the compound XYC double bond CXY, so they can be drawn into 2 different. This type of stereoisomerism. It is a type of stereoisomerism. What is the cis form? When carbon containing double bonds, suppose these are 2 carbons which contain double bond, there will be 2 more bonds, 2 more single bonds in this carbon, and second carbon will also have 2 bonds. X is attached here and Y is attached here. If in the second carbon the X is same side of the first carbon here and here, if it is X here and Y is here, so both the X same groups are same side of the carbon, that will be called the cis form. This is the cis form. If in case of the same group are at the opposite position of the carbon, that means C double bond C. Here there will be 2 bonds, X here and Y here, and in here also 2 bonds, but in this side Y and in this side X. This will be the trans form. This is not a cis form. This will be called trans form. So at the starting, whatever I have shown to you, that this is the compound here, what is the name of this? This is a trans form because the similar group are attached at the opposite side of the carbon. So let us start the geometrical isomers of C2H2Cl2. This is the first example. In this we can draw C double bond C, and there will be 2 bonds in this carbon single bond and 2 more single bond here. If we attach HCl, so both the H are attached at the same side, so it will be the cis form. What will be the IUPAC name of this one? So we can say cis 1,2 dichloroethene. This is the name. We have to add cis 1,2 dichloroethene. On the other hand, if we draw like this, C double bond C, single bond, 2 bonds, and here we are attaching H in this side Cl, but in the second carbon we are attaching Cl this side and H, so you are seeing that both the Cl's are opposite side and both the H's are opposite side, so it will be called the transform. So this have the different name that will be called trans 1,2 dichloroethene. Dichloroethene. So another example, I am going to how to draw the cis transform of any compound. One more example, that is C4H8. C4H8, this is the also showing the geometrical isomerism, and there will be the two forms of the geometrical isomerism. First, what we have to do, we have to draw the carbon and carbon double bond carbon, and we will draw two bonds, single bonds here. That means H and H, both the carbons containing H in same side, and another two carbons CH3, single bond CH3. So it will be the cis form. The name of this compound is cis-butene because the same groups are attached at same side. It will be called cis-butene. On the other hand, we can draw the trans-butene, that will be C double bond C. There we should draw two single bonds in this carbon, so HCH3, and in this carbon we will attach hydrogen in this side and methyl group in this side, so it will be called trans-butene. What are the difference between the trans-butene and cis-butene? You can see that cis-butene, the same groups are attached in same side, and in trans-butene the same groups are not present in the same side, so dipole moment of trans-butene is 0. Dipole moment of trans-butene is 0, while in cis-butene dipole moment will be maximum. Now moving to very important question, what will be the geometrical isomers of C4H4O4? C4H4O4. So it is most important compound. So there are four carbons here. First we have to draw two carbons containing the double bond C double bond C and two single bonds in both the carbons. H we have to draw, and C double OH and C double OH. This is cis form, and we can say what is the name of the cis? Butene 1,4-dioic acid. 1,4-dioic acid. This is the IUPAC name of this, and you can write the common name of this is malic acid, MALEIC, malic acid. And another isomers, that will be the transform of this one, we can write C double bond C, and two bonds in this carbon we attach CH, C double OH, and here H in the opposite position, that is H and C double OH, so it will be called transform, you can say trans-butene 1,4-dioic acid, and the common name of this compound will be the fumaric acid. So students, what you have observed that in this type of compounds which containing carbon double bond carbon, that will show the geometrical isomerism. But at the starting of this video, what I have told, that one more compound it is shown. This video you are watching in the Chemistry Career channel, so please subscribe and on the